Okay, everyone, time for a little bit more rational expression fun. So section 6.3 and 6.4, we are going to add and subtract rational expressions. This has two sections in it because in 6.3 they do very simple ones, 6.4 they do the more complicated ones, but I think we can handle a little bit of both. Okay, so when you're adding and subtracting with monomial denominators, it's pretty simple. Common denominators are necessary. All the rules apply as they normally would to any fraction. Simplify and state the non-permissible values. So the first thing you should always do is get those NPVs right away. So we can see that x cannot be equal to 0 here, and the same thing is also true because 2 times 0 squared would be 0. So what we do, and the way that I like to show this, and I might recommend that you do the same, is we're going to multiply top and bottom by something to get the common denominator. So we can see that we've got x and we've got 2x squared. So what we've got to do is we've got to multiply top and bottom of this guy by 2x. So by doing that, we're going to give these fractions a common denominator. Okay, so this is going to turn into 3 times 2x on top will be 6x. On the bottom, we'll have x times 2x gives me my 2x squared. And then over here, I've got 4 plus x over 2x squared. And of course, when they have the same denominator, you can write it all over 2x squared. And then we've got 6x plus 4 plus x. And from here, we just have to combine like terms. So 6x and x gives me 7x, and then the 4 is a different term. We've got over 2x squared. So we've got this guy here. And of course, we must say x cannot be equal to 0. So this complicated expression over here is the same as this simplified one, provided x is not equal to 0. Okay, here's a different one. For this one, we've got to find the lowest common denominator. So this one, just before I go, I might take a second, write it down, and think about it. What is the lowest common denominator here? We've got a 4, a 2, and a 3. So between those, we've got 12 as the number. Here we've got a b, here we've got an a, and here we've got an ab squared. So we got to make sure that our lowest common denominator contains at least one a, because I see one a here, and it's got to contain at least two b's, because we see two b's here, but only one b over here. So our lowest common denominator will be 12ab squared. So now the challenge will be, what do I have to multiply each of these things by to get my lowest common denominator? I'm going to leave a little bit of space here so that I can fill in the blanks. Okay, so top and bottom for the first one, how do I go from 4b to 12ab squared? I've got to multiply that by 3ab. This next one, how do I go from 2a to 12b squared? That's where I multiply by 6b squared. And then this last one, I just have to multiply top and bottom by 4 because the a and b squared are already there. So when I do this, I wind up getting each one of these fractions is over 12ab squared. So it will be minus 12ab squared. And this one will be plus 12ab squared. So what goes up top here, don't forget that we've got the brackets. So we've got to multiply 3ab in there. So we've got 3a squared b, and then plus 9ab. This one is just 6b squared times 1, so that's easy. That's just 6b squared. And then this one is 4 times a, which is 4a. So that all goes together over 12ab squared. And now we just have to collect the like terms. So we've got 3a squared b, we've got 9ab, we've got 6b squared, and 4a. They've all got different mixtures of variables with different exponents. So we're just going to go, I'm gonna start with a's. It doesn't really matter. So we've got the positive 4a here, so there's the positive sign. We've got negative 6b squared. Then we add to it, I'm going to put 9ab there, and then I'm going to add 3a squared b. So I'm kind of going in sort of a lowest degree situation here. I didn't do non-permissible values, but it's okay. I can always go back and do this. So we can see that b cannot be equal to 0. We can see that a cannot be equal to 0. And same thing over here. So what we've got is we've got a and b cannot be equal to 0. And this would be our simplification. Now, one thought I just had is I looked at this and I saw numbers like 4, 6, 9, 3, and 12, and I thought maybe there's something I could simplify at the end. Sometimes that will happen. In this case, there is no common divisor to 4, 6, 9, 3, and 12, so that's as far as we can go. Here's one more, a little more, I don't know if this is more complicated, it's just another one. You might consider giving this a try. Feel free to pause the video and give it a shot. My first thing I would recommend, get the LCD and also what are the non-permissible values. So you can actually see by looking at all of these x, oh, that one doesn't have one. X cannot be equal to 0 is our only non-permissible value. The lowest common denominator between 8, 3, and 6. You've got to work this out, so you can kind of take some lucky guesses. Now you could say something like, I feel like 24 should work. Is 24 divisible by 8? Yeah. Is it divisible by 3? Yes. And 6? Yeah. And of course, we've got x squared, we've got x, and we've got 6, so it's going to be 24x squared. By the way, if you are completely lost and you don't know what the lowest common denominator is, what you can do is you can prime factor each of these numbers. And when you prime factor, you will find that 8 is consists of 3 2's. 3 consists of a 3, don't even worry about 1s, they're wasting time, and 6 consists of a 2 and a 3. So what you do is you go through and you see that, well, if this one has 3 2's, or you could write it as 2 cubed, so 8 consists of 2 cubed, 3 just consists of 3 to the power of 1, and 6 consists of 2 to the power of 1 times 3 to the power of 1. What you do is you go through and you look for each different factor. So we've got 2's and 3's, and you find, well, which one has the biggest power? So this one has the largest power. So this is the largest power of 2's. And then this one or this one, doesn't really matter. This is the largest power of 3's. And the way that you would get this, get the LCD from this, is you would say the LCD contains 2 cubed times 3 to the power of 1. If you've got 2 cubed, you've already got enough 2's to cover this guy here, and if you've got 3 to the power of 1, you've already got enough 3's to cover this one here. So that means 2 cubed times 3 to the power of 1, that's like 8 times 3, which is 24. Right. So I don't know if that's a process people necessarily go through in their head. Quite often they can just sort of figure it out, but that's the systematic way to get a lowest common denominator. All right, so now we go 2x plus 1 over 8x squared, and what that is going to give us here. Okay, I'm going to leave a little bit of space here because I'm not quite done turning that into the lowest common denominator. And this is 8 minus x over 6. Get out of there, you beautiful, beautiful man. All right, so what we're going to do is we're going to multiply this top and bottom. How do we go from 8x squared to 24x squared? 3 over 3. How do we go from 3x to 24x squared? We go 8x. And then same with this one, we're going to multiply 4x squared, top and bottom. Don't forget to put brackets in when you're multiplying. In fact, all of these require brackets. Okay, working this one out. So the 3's going in there. I'm gonna go ahead and do this first, actually. Let's get this taken care of. Okay. So the 3 multiplies in there to get us 6x, and it multiplies in there to get us 3. This multiplies in there to get 32x, and this multiplies to get minus, whoops, that's 32x squared, and this gets us 32x. And then this one here, I need this to be a minus sign. I think there's an accidental little mark there. This should be a minus sign because of this one right here. So I'm going to ignore that minus sign. I'm going to multiply 4x squared in there to get 32x squared. And then I'm also going to multiply 4x squared to get 4x cubed with that x over there. Okay, so putting this all over 24x squared and combining all the like terms, what I am going to do is I'm going to grab, let's see here, so just grab my highlighter, 32x squared here and a minus 32x squared, they're actually gone. And don't forget about that minus sign in general. So my largest term will be minus negative 4x cubed, so I'm actually going to get positive 4x cubed. The 32x squareds cancel out. Here I've got positive plus negative 32x. So the way I'm going to write that is just minus 32x, but I've also got to add 6x. So it's not minus 32x, it's going to be minus 26x. And then I've got a plus 3 here at the end. Now you look at this and you go, is this divisible by anything? No, I don't think so. So looks like we're good. The only thing I have to say is also x cannot be equal to 0. And I believe, assuming I didn't make any mistakes, I believe that is the answer. So I've got 4x cubed, which makes sense there, minus 26x plus 3, then over this whole guy there. All right. Okay, so let's have a look at the lowest common denominator for polynomials. We talked about that a little bit, but it's going to get just a little more general right now. So to find the lowest common denominator with polynomials, what we're going to find is we're going to want to factor each denominator completely and then cancel factors if possible. So in the last slide, or maybe it was 2 ago, we wound up doing something like this where we took numbers like 8 and 6 and 3, and we wound up actually factoring them to see what they're made of, essentially. So we do a similar sort of thing here, because if we know what the individual pieces are to each denominator, we can get a sense of what the lowest common denominator has to have. And then you could cancel factors, because if something cancels out, then we don't really need to deal with it. You multiply together the unique factors, so that's kind of like how, again, before I went 2 cubed times 3 to the power of 1 gives me 24, so I just did the multiplying thing. Now we're going to multiply it with polynomial factors. And of course, just a little note, if a factor appears twice or more in the same denominator, you get to multiply twice or more to get the lowest common. So that's the same sort of thing, like we saw how 2 to the power of 3 was contained within 8, so we needed to have 3 2's in. And same thing, if we wind up seeing a factor show up multiple times, we're going to have to get it in there multiple times. Anyway, this is hard to explain with words, easy to explain with some examples, so let's just have a look here. In this case, we have 3, okay, so I see that's over x squared minus 4, so I'm just going to do a little factoring thing. I don't really care about the top, but oops, the bottom is what's really important. So all we're doing is we're finding the lowest common denominator. I'm not going to solve the whole thing. So if we want to get the LCD between these two, I mean, it's not really obvious what it is when you've got some polynomials here. But by factoring, we can see, let's see, this one factors into x minus 2 and x minus 1. So what we can see here is we want to see what the unique factors are. So what I mean by unique is I mean they're different. So the unique factors, we can look at this and we can say that there's an x plus 2 somewhere, there's an x minus 2, and there's an x minus 1. This one we're not going to worry about. We don't count this one twice because it, well, we only need a single power. Okay, I'm trying to write the word count and it's not working super well, so let's just say, okay, don't count this one again. Now I said if a factor appears twice or more in the same denominator, like if this was x minus 2 squared, then we'd have to keep 2 of them, but if it shows up in a separate one, we don't count that again. So lowest common denominator, it must contain an x plus 2, it must contain an x minus 2, and then it must contain an x minus 1. And you only need one of each, okay? For this next one, let's have a little look. Factoring the bottom of this fully, we're going to factor out a 2, and 2x squared is actually going to come out. This will leave us with x, and this will be minus 3. this will have for us 3x, and then this has x minus 3 squared. So when we get to looking at the unique factors, there are, let's say there's a 2 and a 3, so those are actually their own kind of unique factors. There's an x, and then there's an x minus 3. Now this one, of course, contains 2, so since that's the highest power, that tells me the lowest common denominator has to contain 2 x's. And over here, this one has 2 x minus 3's, and there's 1 x minus 3 over here. So what our lowest common denominator has to contain? It must have a 2, it must have a 3, it's got to have an x squared, and it has to have an x minus 3 squared. So that becomes 6x squared, x minus 3 squared. Remember, the check is if you wanted to divide your lowest common denominator by either this or this, you should be able to do that. So is it possible to divide 6x squared by 2x squared? Yes, it is. Is it possible to divide 6x squared by 3x? Yes. Same thing. Is it possible to divide x minus 3 squared by x minus 3? Or divided by x minus 3 squared? Those are both possible, so this is a good lowest common denominator. Alright, so that is something just to keep in mind as you're going forward looking for lowest common denominators. Now this is not really too tricky. We can see this is already factored. We can look at this and we can say the lowest common denominator, it better contain an x minus 2 and it better contain an x plus 1. A lot of the times it's going to be pretty obvious here. And we might not have to do a bunch of stuff like in that last example where it's a complicated denominator, but sometimes it might. We'll also grab the non-permissible values here. So x cannot be equal to 2, and this one says x cannot be equal to -1. Once we're done that, we're going to simplify, so we're going to simply multiply this by whatever it takes to get to that lowest common denominator. And in this case, it's actually really obvious. We can just multiply the first fraction by x plus 1 over x plus 1. And then the next fraction, we're going to multiply this by x minus 2 over x minus 2. And that is going to give us what we need. Don't forget brackets goes around here, around here. Brackets actually belong everywhere. Let's just fix that one. You could even put them on the bottom. I'm not going to worry about showing that really too much because the bottom is generally going to get left as a polynomial. We're not going to actually FOIL that stuff out. But the top you definitely do want to FOIL because you need to see if like terms combine. So this is going to become x squared minus 1 because that's a difference of squares. The other term over here will be let's see, x squared plus 3x minus 2x plus xo minus 6. Okay, once we're here, we can now combine like terms. We've got an x squared and an x squared. The whole thing's going to be over x minus 2 and x plus 1. And we've got x squared plus x squared, so we're going to have 2x squared. We've got a single plus x over there. We've got a minus 1 here and a minus 6, so it's going to be minus 7. And that's as far as we can go. We do have to write down here -1 and 2 are the values of x for which this simplification would not be correct. And if we do all that, we got it. Okay, here's just another one. So this one's a little trickier. First of all, let's factor this out. So the best way to do this, I think, I'm going to do it below. So we've got a minus 3 here. What's the bottom going to factor into? Looks like a plus 6 and a minus 3. Over here, this is going to factor into a plus 5 and a minus 4. Okay, now before you start getting all excited and doing things, grab your non-permissible values here. So your non-permissible values, a cannot be equal to, we can see we have a -6, we have 3, we also have a -5, and we have a 4 for those 4 terms respectively. Before we start getting a lowest common denominator, let's acknowledge that this and this will cancel for any other value than those 4. And what that means is this doesn't get included in the LCD. We don't need to make sure that we have that there because it is going to effectively cancel out. So our lowest common denominator for this is a plus 6, a plus 5, and a minus 4. So this thing's going to actually turn into the first fraction the first fraction simplifies into just 1 over a plus 6. I'll leave a little space to multiply that by something, and then the other one is going to look like this here. So what is it that I need to multiply everything by? So I need to multiply this top and bottom with an a plus 5 and an a minus 4. Didn't really give myself enough room, but oh well. And then this one over here, I just need to multiply top and bottom by a plus 6. Make sure you get brackets around that top guy. Okay, so we have a plus 6, a plus 5, a minus 4, and then the other one is going to be the same thing. And yes, this is a little tedious to write it all out. You're probably going to want to skip some steps, and that's not even necessarily awful. Okay, so we multiply a plus 5 and a minus 4, a squared plus a minus 20, and we multiply a minus 2 and a plus 6, so a squared plus 6a minus 2a, so that's plus 4a, and we'll have minus 12. Don't forget that when there's a negative sign, this affects all of them, so just remember that when you're collecting like terms that you are grabbing all of the terms and you're getting all the signs correct. So we're going to have a squared and minus a squared, so they actually cancel out. We have a minus 4a, so we get negative 3a. Then we get negative 20 minus negative 12, so that's like negative 20 plus 12, which is negative 8. This looks like it's pretty good, and maybe just I'll relist the non-permissible values over here. I'll put them in the correct ascending order. And just like that, well, not just like that, because that was actually a reasonable bit of work, but there we go. We did get it done, and I'm happy with that result. All right, looks like we got one more. Is that it? Okay, that's going to be the last one, so this might be one for you to try if you haven't. Otherwise, I'll just go ahead and I'll do this one. Maybe with a touch less narration, just because let's just get her done. So, one thing I will say here is we do have a multiplication, so it's not really going to change things too much. But I will I'll point something out here. I'm going to factor this first, then I'm going to multiply by this, and then I'm going to subtract that. Okay, so my non-permissible values, we can see here we've got x cannot equal negative 1, here we've got x cannot equal 1, and then here we've got x cannot equal 2. So x cannot equal negative 1, 1, or 2. Once you've got the non-permissibles, this and this can cancel because they're going across a multiply sign. Okay, so I haven't done any lowest common denominator business. I've just tried to clean things up a little bit here. So this is what it reduces down to. And now I can get my LCD. So looking at this, I have to have a 2, I have to have an x plus 1, and I have an x minus 2. Okay, just to save a little bit of writing, I'm going to move this over, leave myself a little bit of room here. I'm going to show this all in one step. Okay, and then this one is going to get multiplied by 2 and x plus 1, 2 and x plus 1. Okay, so what we wind up getting, This will be x cubed minus 2x squared, and then this will be minus 4x squared time plus 2x. I think I got that all right. I'm not even going to write the denominator for this step because I'll just combine it all here. The denominator for the whole thing is x plus 1 and x minus 2. And we've got x cubed up top. We've got minus 2x squared minus 4x squared, so that's minus 6x squared. And then we've got minus 2x. You can see if x can get factored out of that, but that's not even super duper necessary. Okay, so that's actually a pretty decent final answer, and we'll go ahead and we'll write in our non-permissible values, and I'm pretty happy with this one here as well. Okay, for some reason I have the sneaking suspicion that I might have made a mistake, or I might have done something too quick in my head. I hope I didn't. Oh, I did. I knew it. Okay, I did make a mistake. My brain was telling me something was wrong. This one should be a 4x. Because when you multiply the two here, I guess what I probably could have done is I could have thought of this as 2x plus 2. So 2x times 2x is 4x squared. And 2x times 2 would give me my 4x there. And then when you subtract, we have the 4. Okay, I knew something was wrong. It's funny how your brain can tell you that. Maybe it just knew because I was maybe skipping a step in my head or something like that. But there you go, and I hope that's correct. And if that's not, well, you can write down in the comments what a terrible, terrible guy I am. But I'm getting a little tired, and I think, you know, for the most part, there's the idea. So hope it's all good. See you later.